I think one of the cool things about being a materials science company who identifies as a materials science company is that we're not drying up the market, right? We're focused on where can we leverage this technology to be able to support our mission, which is what I was talking about of the making the world safer, healthier, and more productive. And that's a pretty broad mission, right? We can play in a lot of different spaces and work with a lot of different people where like we know that the impact that we can have with our technology is worth making.
Hello, everyone. Welcome back to the It's a Material World podcast. I'm your host, Puneeth Upadhyaya. I have my co-host, David, alongside me, and we're going to play a quick guessing game today.
Yeah, so it's going to be relevant to our episode today, but Puneeth, how many COVID-19 tests have been performed in the United States as of November 8, 2022?
Yeah, I'm trying to explain my thought process here while giving an estimate,
Yes.
The classic consulting answer. But there's around 300 million people in the US, right? And I would say maybe on average, each person has taken, let's say, 3 COVID tests over the past, few years. Probably more, but I don't know, vastly different populations and everything like that. So that would put me at around 900 million. But the question is, how many have been made? Is that
how many have been performed?
How many have been performed? Okay. I'm going to go over that 900 million estimate and say 1.5 billion.
Wow. So even the babies are getting tested in this case?
Well, some people are getting more than 3 to 5. So that's my estimate.
Yeah, well, you're within the range. It's 1.1 billion tests have been performed.
That's not bad. That's pretty good, right?
and so the reason why this is correlated with today is today we talk with Porex, a company specializing in porous materials. And we get to talk about later in the episode how we can use these porous materials to make very fast and home kits for a lot of different tests. He was talking about pregnancy tests, but this ranges to a lot of different applications of COVID-19 and all these other regional variants, such as the flu, that could potentially be within the span, given enough time and energy. And so I thought that was one of the coolest parts of today, where we're talking about what does the future hold for something that it's pretty basic once you understand the science, but the way that you can manipulate pores, pore size, and pore arrangement can have such great variations in the performance and properties. So I thought that was a really interesting part of the conversation today.
Yeah, for sure. And to give kind of that versatility, right? Porex components could also be used in Crayola's marker nibs, the tip of the markers too. So that just shows the versatility of this space and of porous plastics. And that was just interesting to me. It's not something I would ever have thought of. And so I would just recommend kind of tuning into the rest of the episode to see what the material science behind each of these applications from the life sciences perspective, all the way to these, unique, subtle applications that you might never think of. And then I guess another kind of favorite part of the episode was just his advice for materials engineers, especially those who are in college and still figuring out, what you're passionate about. He talks about really just tuning into everybody else's whys and recognizing just how different whys are, your passion for metals or your passion for healthcare applications, things like that, and continuously reflecting on that to figure it out for yourself. So that was also really good advice. And he kind of also goes into some of the opportunities that are available at Porex. So yeah, did you have anything else to add in terms of your favorite part of the episode?
Yeah, no, just his insight. He holds a very unique position, which is in between R&D, manufacturing, and business. And so he takes a lot of potentially vague requests and creates a final product. to be used. And so hearing his experience, hearing his expertise was all very interesting. And so it gives a really wide range of examples of what different positions do along like the life cycle of the product. And so we get into different aspects of his job and his role. And it's all very interesting, especially if you have an interest in like product management, but as an engineer. So all very interesting and all very insightful for that different type of engineering that not many people will think of.
Yeah. And it's even more unique within the company where they create very personalized solutions for their customers. So it's not a one size fits all product. They have kind of a starter kit, and they customize that based on the customer needs. So it's all just a very fascinating episode. I really enjoyed it. So without further ado, let's get into it.
Metamaterial Inc. is a developer of high-performance functional materials and nanocomposites. Meta delivers previously unachievable performance across a range of applications by inventing, designing, developing, and manufacturing sustainable, highly functional materials. Meta is a fast-growing company with a positive and committed work culture and a phenomenally talented workforce. Our employees are inspired to do exceptional and innovative work and are proud to contribute to the success of the company, and they are our greatest asset. Meta attracts people from all countries and cultures with over 35 spoken languages represented across all our teams. Meta believes that diversity drives creativity and innovation. With locations in Canada, the United States, the UK, and Greece, Meta is growing and is looking for new talented people to join the team. If you're passionate about doing your best work, making a difference, and having fun while doing it, apply to one of our open positions at metamaterial.com/careers.
Hi, everyone. We are super excited to welcome Robert Kiblinger onto the show today. Robert is a product development engineer and lab manager at Porex, which is a company dedicated to developing innovative porous material solutions for life sciences, consumer, and industrial applications, which we will dive into later in this episode. And Robert is also an MSE graduate from Georgia Tech, a former president of Material Advantage, the Georgia Tech chapter, and he has multiple internship experiences. So we're excited to hear his advice in addition to uncovering, the hidden applications of porous plastics. And we have a lot of commonality, so I'm excited to dive into that too. So thank you so much for joining us today, Robert.
Thanks for having me.
Yeah, like Puneet said, you have a wide range of work experiences, whether it be internship or otherwise, but you've had experiences at Applied Technical Services, Ethicon, GE Aviation, and PolyOne before finally eventually landing at Porex and spending the last 4.5 years at this company. We could spend a whole episode on any of these experiences, but for the purpose of this discussion, could you explain what about Porex made it stand out from the rest and what made you decide to stay there for the long term?
Sure. So, great experience, a lot of fun at so many different places. I've been very blessed with really good bosses at each of those places that have given me the opportunity to learn and grow as an engineer. So when I was looking for a career move and I was looking at Porex and evaluating things, I talked to the people who worked there, and the interview went really well. The people were the kind of people that I wanted to work with. The materials science was like really cool because they knew that their material science was something important to the success of their company. And then from a structural standpoint, I had worked for some very large companies and I worked for some very small companies. And so I got to see kind of that whole range. And Porex sat in this cool space in the market where they were large enough that they had like HR and all of these different departments, which you might not have in a startup company, but they also had the market that they were going after that was large enough that they could really make an impact and have also the diversity. Because when I walked into one company and they were making one product that had a lot of pieces, idea of working with 2,000 different product codes for this company, Forex, told me as a young engineer, I'm not ever going to get bored. And then after looking at company dynamics, being able to be in a product development role specifically was exciting for me because I had done the R&D side where you maybe don't have that true connection to manufacturing. And then I had talked to people who were more on the business side who had no clue how the engineering and manufacturing worked, that was far away. So to find a company where manufacturing is in the same place that the CEO sat, that all the different people kind of could come together and collaborate was really exciting to me.
That's interesting. So what exactly is a product development engineer role? Like, what does that entail? Is it a mix of like the design and the manufacturing?
Yes. And so that's been the really interesting thing is I'm sure any of you engineers on this call have had experience with products where you wonder why the people designed it that way.
Yep.
And so I've gotten to learn about this whole new world where it's not just
Mhm.
science of how do you get the math right and design the perfect theoretical problem assuming no gravity. It's great when you have the manufacturing facility right there so that basically my role as a product development engineer is to stand in the middle between the needs of the customer and what we can actually manufacture. Business development, marketing leaders try to find where we need to go as a company, where could we push our technology to advance material science in an industry. And then sales does a really good job of trying to connect with the customer and figure out what they really need on a business level. And I get the opportunity to stand in the next role of saying, okay, I hear that you need products that are in spaces that we know we can support. So what does it look
Mhm.
like to actually get numbers for what you need in terms of strength and
Mhm.
physical properties and chemical properties in terms of what do you need to resist? And then
Mhm.
at the end of the day, it's what are we filtering? What are we absorbing? What are we wicking? What are we venting? What are we
Mhm.
applying? All the functional components where we get to have these really fun technical conversations, sometimes with their business people, and then sometimes with their engineers, where they have
Mhm.
tough constraints and we're going to try to fit into a very tight box.
Mhm.
And I get to talk with my manufacturing team to see what it takes us to make that actually happen.
So I'm sure that a lot of us, and this is probably truer for maybe the older generation, sometimes when they try to explain things, that it doesn't do a great job of saying exactly what you want. And so now it's up to you to interpret what they want, which could be very imprecise, especially for business people. How do you, in your role, take very vague answers and be most efficient with those vague answers to make actually something that they do want, and not, oh, this wasn't exactly what we wanted?
Yeah, that's a great question. And that's truly a challenge every day, right? We talk
Mhm.
about language. And so there's multiple types of language, right? There's technical language and then there's the business language. So we've got to come across that barrier. Plus, we have multiple languages, right? As a global company, we're supporting people who are using the same English words that are meaning different things because we're going through a language transition. And so, especially if
Mm.
I'm dropping things into one of the translators and trying to work with someone else on my team who understands that language better than I do, there's real challenges along those lines. And that's where a lot of times it really takes finesse and it really takes those engineering connections, right? When
Mm.
you're talking to their marketing person and they say it needs to be softer, and then you get to talk to their engineer and say it needs to be strong enough it doesn't break, then when you get to be in a product development role and you get to kind of connect those dots and talk to people about what they really need, because at the end of the day, if we can make the customers happy and we can also make their engineers happy, then it's a win-win. So it's a lot of talking back and forth, and that's where Porex as a company has decided that we want to sit, because if we were offering a standard product, then a customer could figure out how to do it, right? They could buy different housing. They could go a lot of money on some other angle to use a standard material to do a standard thing. And as a company, what we've found is that what makes our customers differentiated or disruptive in their markets is when we can actually solve what they need on a very technical level that makes their business and marketing people also happy.
Nice. So from the material science perspective, it seems like you've worked with a variety of material classes, like I'm assuming with GE Aviation, a lot of alloys, right? And then Poly One and Porex now from the plastics and polymer side. So did that experience level and interest maybe in different materials influence your decision ultimately, or no? Or was it just like a love of material science?
I do love material science. So that's an easy part. When I was in school, then I didn't know which path I wanted to pursue. I didn't know what material was worth committing my whole life to. And so I ended up trying multiple options, right? Ethicon was in the polymers family and did some really cool wet chemistry. And then in the GE, yeah, it was high temperature super alloys. that are fascinating, right? Cutting edge.
Yeah.
And that's where if you're working with a Fortune 50 company, you're going to be on that cutting edge of like, what is the new material that we're innovating? And so that was exciting. And what I found in Porex was that we got to focus more on the application. And so instead of having as many PhD researching employees on our payroll, what we do is we really kind of have our pulse of the market, and we're looking ahead at what kind of startups and what kind of research is being done that we think that we would be able to really support, right? We're looking at everything from a perspective of how can we actually make the world safer, healthier, more productive. And so we're not maybe the cutting edge new plastics that we're like formulating in a research lab that will be useful 10, 15 years from now. But what we do is any new plastic that comes on the market, we're going to check it out. We're going to see if it works for us from a filtering standpoint or a wicking standpoint. What can we functionally add to these new materials that other people maybe did the R&D work for, that we can functionally use in supporting our customers?
And so, like you've alluded to, Porex works on porous materials. So before we dive into the applications of Porex components, could you talk us through the different types of polymers that fall under this porous tag and the structure property relationships that come up with these types of plastics?
Sure. So like I was saying, we've tried a lot of stuff. We work off of a couple different technology platforms. We work with foam, we work with track etch membranes, we work with fibers, and we work with sintered particles. And so within the space of porous materials, we use a lot of different polymer families. Most of them are the more common ones, though. So we use some nylons, we use some PTFEs, we use some of the kind of on the edge stuff, but a lot of our business is polyolefins and polyesters, because we can functionally tune our process to be able to deliver the functional performance with using different polymers that are familiar, right? You take classes and you learn a lot about the polyethylenes and the polypropylenes, and you use a lot of products in your daily life that use polyolefin sort of materials. So the cool thing for us is to be able to combine materials in unique ways and add functionality like color change and self-sealing and these different properties like color that can help a customer achieve what they're looking for. But we don't maybe pursue what the Fortune 50 companies have a fleet of research scientists exploring.
So then when you're developing these like personalized solutions for your partners, for your buyers, I'm just wondering, is that usually more like modifying the structure of the existing materials you're working with, or modifying processing parameters, or is it a mixture of both?
That's the exciting thing of working for a company that knows that material science is important, is that we do get to do both, right? In other manufacturing environments, then the material comes in and you use it and all you can do is turn knobs up and down. And so that's been a really cool thing of working with Porex, is that we've been hiring and have historically had a lot of material science engineers working for us, doing the materials innovation, but also to be able to make millions and millions of quality product that's delivered on time. We do a lot of really cool machine optimization, really cool testing, really cool internal analysis to be able to figure out what's the best product for us to make for the customer. Because ultimately we want a win-win, right? We want something that works really well for the customer from a form, fit, and function. Also works within our forums of manufacturing of the man, the method, the material, and the machine.
Got it. And so then I'm wondering, just before we dive into the applications, like what unique characteristics do these materials have that allow them to have this like versatility in a wide variety of industries?
Yeah. So fundamentally, they're porous, right? The way that you can measure that, there's a couple of different ways you can measure it, but one of the good ones is looking at the pore size and the pore volume. So figure out if you're trying to filter out a particle, let's say, because a lot of our customers are filtering, then what is the size of the particle you want to stop? And then let's make the distribution of the holes, right? Because in the real world, everything's not the textbook diameter of the hole. It's a distribution. And so we just set the distribution of our part to be able to match with what the customer is trying to selectively filter out. And so in terms of our materials, we have materials that are very clean, for the medical or healthcare or what we call life sciences industry to be able to support all kinds of different applications and diagnostics and components of a product that functionally needs to wick, absorb, filter, vent, or apply a sort of solution or fluid. And so then that's where the materials portfolio that we have is always growing as well. We have different capabilities we can add to our materials to be able to give them more of a distinguishing feature so that our customers can outbeat the competition.
And so before we jump into the applications, you've said this set of words multiple times. It's vent, wick. I'm forgetting the rest. But you're describing different types of ways that you interact. Could you just quickly like break it down like a sentence each? What does each one mean? Because from someone who doesn't know too much about porous materials, like I'm having a hard time distinguishing what the difference between wicking and venting is.
Sure. So I'll start with wicking. Lab classroom question. Have you ever used a paper towel before?
Yes. I was expecting a much more complicated question. Maybe we'll get one soon.
Keep it really simple first. So,
nice.
Fundamentally, if you had a absorbent material and you were to put some sort of fluid in contact with that absorbent material, so like this is a fibrous material, somewhat flexible, somewhat rigid, and if I was to dip it into my water, then what is going to happen?
It will absorb the water.
Okay, by which principle?
Capillary action?
Yes.
Nice.
Exactly.
Nice.
All right, I'm loving this. So the function of wicking is basically the fancy marketing word for using capillary action to do a functional task.
Gotcha.
Right? And that might look like wicking up a material that could have different geometries to be able to emanate a fragrance or emanate an insecticide, or to allow, maybe if we turned it sideways, to have lateral flow across some sort of assay for a diagnostic test kit. And so we can use that wicking sort of application to functionally solve a customer need. In terms of the different sort of applications that we have, we also said venting. And so how would we compare and contrast that to venting? There are a lot of different electronic components out there that may have some sort of a need to balance pressure and allow air to flow, but do not want dirt or dust or water to be allowed in. So you can imagine that from a venting standpoint, that we have customers that need to have, let's say, like a sound go through, or like if you plan on taking any of your electronic devices up in an airplane, you might want the pressure to balance so it doesn't act like your water bottle, because your electronic devices would not bode well with pressure balance issues. So that's been a cool thing where porous media allows what we want to flow through and keeps out what we need to keep out.
Got it. Okay, so then maybe we can dive into an application where like the capillary action kind of comes into play. And so this is something I didn't know, but we talked about this in a previous call, Robert, but Porex has been around for quite a while now, I think around 61 years. And one application that I would never have thought of is the marker nibs, where the ink comes out of. And so Porex is publicly associated with a well-known company in this industry, Crayola, right? And so I was just wondering if you can kind of, in general, explain how this system works and what about porous plastics enable this application, and how do they keep them, safe for all potential users?
Absolutely. So I grew up using markers as a kid, didn't think anything of it, but there's actually some cool science there. So we're saying that we have a safe, washable ink that this company, Crayola, has done an awesome job of making sure that their child safety is their number one priority. And that to make their creatively alive individuals, then they are using our technology that absorbs a bunch of fluid into a reservoir. I don't know if you've ever shaken a Crayola marker before, but you don't your fluid flow. Whereas in some other markers, you do have a free liquid system where you can shake it just like water in your bottle and you can hear things moving. So the team at Crayola realized that if they want to make sure that they don't have ink everywhere when some kid somehow breaks one of their markers, which are very strong and meant not to do that, then they don't have fluid flow everywhere. So then they have happy parents because it is tied up in a reservoir. So the Porex media inside of the pin housing absorbs all of that fluid. And then in terms of capillary action, there is this principle that if we increase the surface area, then the fluid will have more affinity, and the fluid from surface energy has more affinity for the higher surface area environment. And the smaller pore size actually pulls from a larger pore size when they're connected. It's sort of like a galvanic cell between two metals with water in between. It's this crazy phenomena that like we can tune the pore size and the pore volume of our products to be able to have a nib, which is what we call the little marker tip, that is pulling fluid out of that reservoir.
Wow.
And that as you are applying the ink to the paper, then you're just allowing capillary action to do its thing.
That's crazy. And so I guess like the fullerton of it is it, and you can tell us if we can't talk about this, but generally speaking, you're going to have this gradient that's pulling it. And so now the next cost saving thing would to make sure that you can get all of it out. Can you design capillaries in a way that it's so energetically favorable at low concentrations to pull everything out, or will like you always have some left at the end?
Great question. Tough question. I would love to create a perpetual motion machine where we can constantly like pump, right? Physics only gets us so far, right? So the way that things work in the world is that if there is some affinity for the surface, right, then the fluid at some point will stay in the reservoir. The cool thing that our team at Porex has been able to do is to create media that has a really high release so that gets onto like a single digit percentage point instead of like enough that you're worried about it. And so that's been really helpful, like in a cosmetic space where you have a very expensive fluid, or in a medical space where you have a very expensive fluid and you want to make sure that as little of that is left in the delivery device and as much of it as possible is applied. And so that's been a really cool thing where innovation at our company has allowed us to take on new technologies and support markets that have that issue as their main pain point. And as a product development engineer, I have to kind of evaluate what is the thing that they care about the most. And for some of them, that last drop really matters.
And so jumping off that innovation standpoint, Porex itself has changed a lot over time. And since it started, could you tell us how the company has leveraged what you're talking about, the innovation and the R&D with material science as the focus to stay relevant and attached to these new and unique problems across multiple industries?
Yeah, it's been a lot of fun working for Porex, even for the last 4.5 years that I've been here, because I've gotten to see us pursue different markets and build new technology to try to support those markets. We've had multiple different applications where there wasn't really an answer, right? The industry said, can you do this? And we tried to figure out what it took. And so that's where like we've been able to structure teams to respond in different times. We've had a team that, as an example, when COVID happened, then we said, hey, we have the technology to do these lateral flow assays. We have the technology to analyze fluid. We have the ability to absorb. So like, what would it look like for us to have a whole team focus on solutions around responding to this new need in the market? And so we're able to focus a lot of our R&D effort and just launched a part of our company that's like within Porex, within our filtration group parent company, but is a startup. Wow. And it's the hardware that we have the hardware manufactured in Fairburn, and then we do the assembly and we do all the rest of the design through this Porex Life Sciences company. And that's been really cool to be part of a company that's like willing to take some risk, right? That's scary. That's the executives really were decided to go for it on that. And that's something where I've just been really lucky to be part of a team that's willing to be innovative and willing to kind of invest their time and energy and capital in chasing after innovation.
Yeah, but I'm sure that that's a key component to growth, right? And constantly expanding. So I'm just wondering, within your product development engineering role, how many different functions are you interacting with to, be able to connect those user needs to the design requirements?
Microsoft tells me I have a lot of active collaborators.
Got it.
Yeah. So it's cool because being in a product development role, I get to see all the different pieces, right? So I'm looking at what does it take our supply chain to be able to get everything we need to be able to make product and ship it on time, all the way to like the first touch. This morning, I got to talk to a new customer that was a startup company, and they said, "Hey, we have this new technology and we have this idea. Can you support us?" And so the whole gambit, right? I've got all of the internal stakeholders that are in manufacturing and in quality and in engineering for the sustaining side and optimizing of our process. And then I've also got the business people that are saying like, "Hey, can we do this?" So it's really cool to be a part of a team that's collaborative, right? Like the people that we hire to work here are nice people. And that makes it so that as we work on these big challenging problems that have so many different facets, that like we just do our best. And when I was interviewing for this role and I asked my boss to be how many hours they worked last week, then he said 40. And when I asked the engineering director how many hours he worked the week before I started, he said 40. And they've lived that, right? Like there's a certain amount of like, yes, innovate at all costs. Yes, like go after the big thing. But there's also a level of like, hey, if we focus on the right things, then we can do our job and enjoy it and enjoy the people we work with.
And so I think you've already walked us through like what it looks like for a new concept or a new challenge to be brought upon, whether it be the sales team or internally just pushing that narrative. But then from Porex's philosophy almost, what does go about solving it? How do you get new ideas? Once you've exhausted your current portfolio, what does the next step look like in terms of innovation for these challenges that have been arisen?
Yeah, so that's a good question. In terms of exhausting the market, I think one of the cool things about being a materials science company who identifies as a materials science company is that we're not drying up the market, right? We're focused on where can we leverage this technology to be able to support our mission, which is what I was talking about of the making the world safer, healthier, and more productive. And that's a pretty broad mission, right? We can play in a lot of different spaces and work with a lot of different people where like we know that the impact that we can have with our technology is worth making. And so in terms of how do we go after new markets and how do we pursue new things, we're looking ahead to what's next, right? We're trying to stay up to speed on state of the art. We're trying to, stay involved on college campuses, stay involved in research, and then collaborate with our customers, right? We try to have a good mix, right? We want the stable, large companies that have been doing their product for a long time and that have a need for a porous plastic component as their critical function. But we're also talking to all the new people, right? I was talking about this morning, like the way that we stay relevant is that we kind of look at market trends and keep up and keep trying. And eventually we find places to fit. So
yeah, that's awesome. And it seems like even your existing customers can kind of hint at what's next, right? And they start asking you questions like, hey, do you have this? Do you have this? And then that can also kind of steer your direction in terms of how you grow and what solutions you provide, right?
And some of those big customers want to be disruptive, right? Just because they've got a stable product that works doesn't mean they're not also the ones pushing, right? In today's day and age, startups have been king and everybody's been putting all their venture capital money into whatever's a new idea. And that is great. But we've worked with some customers that are actually really pushing the envelope, even as a big company.
Yeah. And so one thing I'm curious about is after doing academic research for almost 6 years now, you said that you keep your ear to the ground on like what's new in academia. And so from a undergraduate standpoint and a graduate standpoint, I don't know if all my research is worth going on to the next stage. So from your point of view, how much, like, I'm sure like a lot of academic science is like understanding the fundamentals, but how much of academic science would you just estimate actually makes it to something like you're doing, where it's now being tested as a potential solution to these new up and coming challenges or improvements upon challenges you've already solved?
I can't
Mhm.
truly answer your question because I
Okay.
don't have enough of a pulse on academia.
Okay.
What I can tell you is
Mhm.
that my company structures, to be able to structure around growth, we try to focus the product development efforts, right, that are looking at the
Mhm.
full picture from customer to prototype to concept to let's make 50, let's make 500, 5,000, 5 million, and then like
Mhm.
pass it off. We only focus on the things that are the best, most likely to succeed. And then when
Mhm.
we have our R&D team, then they go after more of what you're looking at, right?
Okay.
What's the 5-year plan? What's the 10-year plan? What's the 3-year plan? What are the things that are within grasp, but take
Mhm.
effort or take money or take resources? And that's where the more innovative, the more
Mhm.
scientific new, which is
Mhm.
very attractive in academia, then
Mhm.
what that tells me as a product development engineer is that it's a longer time to market. And that's
Okay.
not bad, right? It's that if you're
Mhm.
asking for the failure rate versus the success rate, our company focuses our R&D team to try to stay relevant and to try to
Mhm.
be competitive and try to every new material that comes up, like we're going to evaluate it and we're going to see if we
Mhm.
can use it and make it more effective in one of the areas we need. But the hit rate is lower, right?
Gotcha. Mhm.
So you wouldn't want to be a salesperson that's commission based on the crazy ideas that might happen, hoping for a unicorn startup, as much as like we develop the base business and we innovate on where we've been, and then we also like are looking for the new thing. But in terms of academic research, that's more of a, are we headed the right direction? Does academia look like it's pulling this direction, or do we need to give up on some of the challenging things that we don't see the return in a near term?
Gotcha.
Yeah, there's a balance there. And I think your PR team would be proud of that answer too. So it was very impressive there. But I wanted to take a step back. So I know we've talked about like wicking, venting, right? And there's other functions, absorbing, applying, diffusion, et cetera. And then you've also mentioned kind of characteristics like color change, right? Or self-sealing. Can you help us connect the dots there in terms of like how these mechanisms then can contribute to the properties or kind of the requirements that some of your customers are desiring?
One of the downsides of working for a very cool material science company is that we do so many different things it's hard to keep up with. For me, though, that keeps things very interesting. Example, if you have an application where you have a suction device and you need to make sure that you keep the upstream of the suction device dry, then
Mhm.
you would need some sort of a filter, right? And so we could make a filter that prevents all moisture from coming through. But as you could imagine, if we're looking for the application of preventing water as a liquid from going into a vacuum line, then the pores would need to be very, very small. What that would mean is that you would need to have a very large motor or fan pulling the vacuum to be able to suck it through those very, very tight pores.
Mhm.
That's where what we can do is we have some different technology like the self-sealing sort of application where we say, hey, let's use a more open pore size. Let's allow more of the air to flow through, but see what we can do from a functionalizing standpoint, whether that's through our manufacturing process or from working with additives, uh, to be able to give us a function that we don't currently have. And so in that case, what we've found is instead of having metal clamps and a moisture sensor to emergency seal that need O-rings to be able to stop any fluid, if the moisture sensor detects something and then the actuator closes,
Gets
is
complicated.
right, which it would be an effective solution. And that's where
Mhm.
we work with engineers at companies who have effective solutions. And sometimes what we can do is we can come in with a very simple solution by having a porous media that has a self-sealing technology where when it hits moisture, the pores that were open seal.
Mm-hmm.
In which case now we have taken a very complex problem and a very complex solution and used the material science to solve the problem, which adds value to our customer and simplifies things. And they get a supply chain of one product shipped from Porex in Fairburn, Georgia, instead of whatever complexity they were previously taking on.
So when the pore closes, does the water, what does the water do? Or it just sits there and it's like a disposable, instead of having this highly engineered, you just put in a new filter every 6 months and you're good to go?
Yes. So that's where some of our business model is things that are filtering and function, and there's a way to like self wipe or clean and then reuse. And then some of our applications, which a lot of times in the life sciences or stuff that interacts with people's bodies, you don't maybe want to reuse those things. And so having a very simple disposable component instead of a very complex system ends up working out better.
So even in one industry, it seems like you can kind of gear your materials to have multiple applications and use cases. So I'm just wondering, like, what type of infrastructure is needed to create those very personalized solutions for multiple different companies? Whereas, other business models are just like, here's your, one size fits all solution and scales that way.
Right. That's a great question. So one is that we have to have a team to be able to support it, right? You're talking to me as a product development engineer, and I have a team behind me with a product development lab where we have a lot of different manufacturing options and we have a lot of different material options. And the cool thing that we do with our customers is that we give them some standard samples as a starting point, right? Tell me if you like this from a structural standpoint. Tell me if this works from a chemical compatibility standpoint for you. Tell me if this wicks enough fluid. And then from there, we have the opportunity to customize. And so that's where my team gets a request through our sales group, and it comes in as an engineering service order where we say, hey, let's see if we can make a product for this customer that has these properties that are different than what we already know and customize something for them. So sometimes that needs tooling, and sometimes that needs super fast timelines where the customer is really innovating fast and they've already tried some other options and they're looking at a porous plastic solution as an option for them. And so we have to be very cross-trained on the different technologies and very dynamic and very responsive. So there are times when my team has a lot of work to do and a lot of challenges. And some of those challenges are on the process side, right? The customer says, can you do this? And we say, we will try. And we go back to the drawing board and we tell them, hey, your housing has to change, or the way that you're planning on using this puts too much torque on this sort of geometry. And so it's always a conversation, right? It always goes back to how do we solve the problems in a way that is the most satisfying for the customer and is also a win-win for our two companies.
Yeah. And so you've mentioned this before, but instead of having the normal, you just tweak the process parameters. Porex takes on, let's tweak the materials and the process together, which basically squares the amount of possibilities. How does that complexity figure in? And then what are some of the ways Porex decides, whether that be data-driven or past knowledge, or just like a hash map of, we know what all these things do and try to interpolate almost?
That's a very insightful question. You said academia, right?
Yeah.
For 6 years of academia, you have a pretty good pulse on industry.
Yes. Well, as a wording, I did do pilot scale manufacturing for Tesla. So
Cool.
I got thrown to the fire there. So just thinking of some things that were, I was just controlling the process, and there's like hundreds of variables and working with 4 teams to like try to get this to work. And so then adding like another like why, and now you're doing all these more. Yeah, it's so yes, I'm very interested to hear what you have to say now.
Yes. So there's a reason why we have a team of product development engineers instead of one. Right? There's some companies that run very lean and they don't have a lot of engineering support because they do have really great machines, right? They've spent their time, they spent their money, and they have all of the things worked out. So all they do is turn a knob up and down. the reality of the world, right? Like you've experienced, is the knob that turns up and down can also turn so many other directions. So many components of any machine
Mhm.
add complexity, right? Which is beautiful in an engineering design standpoint because it
Mhm.
means we can make all of the different things. But with great complexity comes great responsibility in terms of how do you manage that.
The
And
material Spider-Man.
yes, 1,000%. So the challenge is very much a team challenge, right? I cannot solve this all by myself. And so what we do is we have different teammates that specialize, where
Mhm.
one engineer might be focused on a specific market and they get to know that market so well and the needs of that market from a
Mhm.
technical standpoint, right? That
Mhm.
they focus their materials into one specific area and then work with certain machines. And then we have different manufacturing sites as well, where some of those manufacturing sites have multiple options, but they might specialize in one. So we had our company set up from different technologies to have a center of excellence, where if you were doing some sort of product and you thought it needed to go into that technology, it would go to the team that knew the details of those materials and the details of those processes the most. And so any company tries to mix things up and change the focus to make sure that you've cross-trained and you've learned all the different pieces of the business. But the short answer is yes, we are a highly complex company. And that allows us to be able to make custom solutions at the cost of, I think in the last 4 years, I have learned something new so often. And I'm just now hitting my stride that I would say I'm a great product development engineer.
Wow.
But I would not have said that a year ago or 2 years.
That's awesome. That's so cool though that you get to learn something like new basically like every day, or with each project and each customer. I'm just wondering, does the company have to be selective when there's so many variables to consider, like time commitment, right, and the resources you have, and I guess money as well, obviously. So I'm just wondering there.
Yeah, and that's where, bigger picture, we're part of an organization called Madison Industries, and that's got a filtration group of companies, and we're within Porex, and I'm within a manufacturing site. That's an awesome manufacturing site in Atlanta. But like there's a bigger picture, and that's where our company has really adopted the 80-20 philosophy of saying, how do we focus? If we can, let's see if we can Pareto things out, right? If it's easy for us to make a win-win and the customer really wants to work with us, then maybe we focus on those projects, especially if they're high value. And then if it's something that's really innovative and cutting edge and we want to be a part of it, then we're going to dedicate the resources and prioritize it, even if it has a lot of complexity. And that's very nuanced, right? So that's where we're constantly talking about when there's new projects and new opportunities. We kind of have to filter, if you will, the opportunities to be able to decide worth our time. And so we love working with companies, big and small, but the true challenge is that in order to deliver more of our mission, we need to make sure that we stay focused. And so sometimes those are tough conversations, and sometimes those conversations happen early, and sometimes we learn more later down the road. We definitely have supported some very small startups because we really believed in their idea and in terms of the disruptive technology they were bringing to the space. But it is always easier to go after the big fish.
And so now that you really walked us through like Poritz's philosophy and how we tackle these challenges, let's talk about a new up and coming challenge and maybe how that mindset applies to it. But there's a huge trend in life sciences where you're talking about before, the transverse like diffusion across the membrane, where we could use these as diagnostic kits and doing testing at home and not in a doctor's office. Could you talk about how Porex is carving a niche with their porous plastics in this take-home diagnostic industry?
Yeah, this is a really exciting part of working in an industry in all of the industries that get to actually help people be safer, healthier, more productive, is that you get to see the impact of the products that you make. I remember when I was in college and somebody told me that they liked being able to see the products on the shelf that they helped support, and I didn't really get it. And now I do. So we've been in the diagnostic space for decades, specifically looking at using our lateral flow assays that we were just talking about for pregnancy tests to help expectant mothers get an answer really fast. That's really important. And we get to use the sort of technology that is based on that urine sample evaluation to work in a lot of different spaces. And I think more people are looking for information about their health faster. And it needs to be very accurate. So there's a lot of engineering work that goes into making sure that we collect exactly the right amount of a sample and apply the right amount of a buffer and apply the right chemical indicator that might have a color change. If you've seen lines change on maybe a at-home test kit in the last couple of years, been very popular. And so that's where we use our technology, and we get to use it in ways that you can see the impact. And I would definitely say that the diagnostic space is great for that, because instead of maybe you go to the doctor and then you go into their sample collection area and you give them some sort of sample from your body, and then they thank you and send it to a lab. What we're allowing is the doctors to be able to make a decision in the moment because they have the data in the moment. And we're allowing the person to maybe even stay home. And we're improving the quality of the samples, because I don't know when the last checkup you had was, but ensuring that you gave them the right amount of the sample when it's up to you to decide without anyone else around is sometimes intimidating as a scientist. I don't know if anybody else feels that way, but I definitely have. And we take the guesswork out of that market, right? If we have a porous media that has exactly the right pore size and pore volume within a standard deviation, then we know we're getting the right amount of sample. And then instead of having a tech go and stick it on a centrifuge to be able to separate out the things that we need to separate out to have a very accurate test, if we can use the particle size separation of a filter, because we make filters, to do the filtering so that you only get the sample on the other end of your test kit, then we no longer are waiting for, I don't know what the longest was that you waited, but we're no longer waiting on labs for a really long time when they have a backlog. And there's also, influence of people in the lab that need to make sure that they pipette the right amount. And I think PCR is something that has become a lot more of a household term now than a lab science biology term. And so that's when we've been able to play in that space of helping to make pipette tips to make sure that people don't over pipette the amount of fluid. And it's not always people. Sometimes it's very fancy machines to try to get the fast turnaround from the lab that you want. But even in that space, if we can give you the equivalent accuracy with something that you can keep in your pocket or you can buy at your corner market, then that allows us as humans to respond to our bodies in a much more effective way. And so it's been really cool to see how that market is taking off and using some of the similar technologies that we've developed and specializing those, right? We've been able to work with so many companies that have this passion of this one disease or this one malady that people experience, and they have the team of scientists behind them, right? They know how to do the chemistry and have the chemical indicator that changes the color and maybe has the stripes light up or the dots or whatever their shtick is. And our media allows those companies to be successful because we apply the material science and then the design of the product to functionally flow or filter or absorb or wick or vent or do the thing that needs to be done.
That's fantastic. Yeah, I was about to ask, because we've had episodes in the past where diagnostics have been a key application, for example, like nano biosensors, right? And so I was going to ask, what are the advantages of porous plastics? But it seems like that filter is a key component to it, and basically taking out for human error, whether it's the patient or technician or et cetera.
The other piece of it is also the material, right? When you look at some of these existing products in the market, a lot of them tend to use glass fiber, which is great, right? It's porous. It allows flow. It allows you to absorb. The challenge there is sometimes just the structural properties, right? If you've seen people with glass fiber in their attic, it's not a very strong material. And if you want to keep the pores open, manufacturing of glass fiber has its own challenges. And so that's where we've been able to see that our media can more repeatedly and handle more wear. And that's been really cool because we've been able to take existing technology and figure out what does it look like to innovate on that. And when you hear voice of the customer of people saying, hey, what I'm currently doing sort of works, but I need it to work better, and then we have the option to be able to help them, then that's been a really cool spot to sit in the market.
Cool. So I definitely had so much fun with recording this episode. I learned a lot. And so we would just love for you to kind of wrap up this episode with advice that you would give your past self in college who is still kind of figuring things out, exploring a bunch of different options, and then ultimately figuring out, what are you passionate about?
I would just play off of exactly what you said, which is that people have passion, and it's exciting to be around passionate people. And I think that college is a place where people get to pursue a lot of their passions, right? David said 6 years of research, maybe not the same thing, but like you have to be passionate about that, stick with it for 6 years, which is great. And that's where I think in industry, I'm seeing that if you find a role that you like, then you can do that role, whether it's with the same company or others, but people develop their skills and develop around their passions. And you can be passionate about a lot of things, right? We've got so many different products. So it's not like I am just focused on one medical device market. But I think that as a student, I would have asked professors why they chose to pursue their research more. And I would have, when industry people came to talk, I would have been really interested in their why. And other students, right? My peers of like, some of them were like knew they wanted to work in metals, and I knew that because they were taking the alloys classes maybe, but the conversation of people just to kind of catch some of their passion, I think I could have done a better job of. And I think that all that would do is basically help me understand like what the world is like outside of this and not to get stuck. And I don't feel like I've been stuck in my career. And I think I've been very blessed with good bosses. But that was definitely something that I would have suggested to college me.
Couldn't agree more. I love that advice. And so finally, for Porex or people interested in Porex, what opportunities are available at your company? Maybe you can dive into co-op or other opportunities.
Yeah. So one of the cool things about being in so many different markets is that markets ebb and markets flow, right? Things go up and things go down, but being in a company that's so diversified and that we're able to pivot because we're focused on the material and not the industry, then like we're doing really well right now. And I have friends that maybe don't have a lot of hiring going on at their company, but I'm kind of looking for most roles across the board. We've got people in marketing and people in finance and people in engineering that are looking for full-time co-op and internship. We are even looking at an HR intern, like very much across the board. We are trying to hire more people and gain a larger team because what we see is that we're positioned for growth and that we're doing really well. And I have an open role that I just filled with a Georgia Tech student. And we've got manufacturing co-op roles for spring. We've got summer, we've got fall on the product development team, on our quality team, on our manufacturing team to try to improve and continuously grow our processes. We've worked with all kinds of different people in the material science space, especially. I think we might even have some material science engineering roles. I think we have 3 open right now internally that'll be posted on our website. So that's the other cool thing about being a part of an innovative company is that there's a growth plan and a pipeline, and you get to see how you want to fit and where on that plan you might be able to join. So definitely excited to grow the team and be a part of it.
Great. Well, thank you so much, Robert, for joining us today. I'm very appreciative, and this was a very interesting episode.
So much fun for me.
As a materials engineer, we can make an impact in nearly every single industry.
But with that versatility comes a lot of different options to choose from. So if you have no idea which industry or position is right for you, believe me, you're not alone. I've been there, done that. But just for a moment, imagine narrowing down your ideal role and company by the end of this week. Imagine being able to secure your dream job offer without having to apply to hundreds of job openings. Our online course, MSE Academy, includes video testimonials, resumes, interview prep, and mentorship from materials engineers who have been in your shoes. We also connect our members with companies and industry professionals in our expansive network to help accelerate your job search as much as possible. To learn more and get started, simply click the link in the description below. And if you enroll within the next 24 hours, we'll add 3 bonus career development resources. I hope to see you there.